Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see a problem: most profitable path in a tree. Now, just a big disclaimer: the video is gonna be a bit long, as you can see. It's actually like a lot of stuff which I'm gonna teach you. I'll teach you two approaches, which I'll obviously can bet you no one will teach you. So let's sit back and relax. Again, the first one will be pretty easy, straightforward. The next one will be a bit tricky. Please make sure that you follow the dry run. And again, as usual, notes and everything will be here. And make sure that we hit the like target of 100 likes. Now, starting off, it says that we are given an undirected tree, as you can see, a tree which will have obviously n nodes and labeled from 0 to n-1, and will have all the edges, n-1 edges, because it's a tree. And the edges they are given as ai to bi. The tree is rooted at node 0, so node 0 is the root, and I have the given edges in the form of edges array. So if I go down, edges array is given, the node, root node 0 is given, the bob is a location of bob, alice location is 0 by default, bob location is given to us, which is can be any node from 0 to n-1, and ultimately I've also given some amount array. That amount array indicates that for at each node I have a specific amount. As you can see, for node 0 amount -2, for node 1 amount 4, for node 2 amount 2, for node 3 amount -4, for node 4 amount 6. So this amount is given. What I have to do with this amount? Obviously the amount can be positive and negative both. Now there is something called as, we'll play a game. Alice and Bob, they are very naughty, and they'll play a game. When they'll play a game, Alice will start from node 0 and Bob from its corresponding node, which is given to us. Alice will start from node 0 and Bob from its corresponding node, which is 3. In this case, Bob will start from here. Now, every second, Alice and Bob will move to an adjacent node. But there's a catch here, that Alice will try to go towards any of the leaf node. So Alice will start from here and she can move towards any of the leaf node. And she has to stop at that leaf node itself. While the Bob has only one specific aim. He has to move towards Alice. Again, not necessarily Alice's path, which means let's say Alice moves like this. But Bob's has, okay, I have to move towards node 0 only. That's it. That is the ultimate aim of Bob, which is node 0. That's it. Now, they are given that for every node along their path, Alice and Bob either spend money to open the gate or accept the reward. As you can see that the amounts are negative and positive. Negative indicates I am spending some money. Positive indicates, okay, I am getting some reward. So whenever you go on to any location, you have to accept that amount, even if it is negative or positive, no matter what. Your ultimate task is that maximize the net income for Alice, which means that Alice will get some score and you have to maximize that specific score. Obviously, there is some catch which we have missed. That catch is that if the gate is already opened by anyone, for example, if Alice is coming like this, but Bob has already received those score. So when the Bob has received it, so it will become 0. That's a catch. And if both of them reach at the same point at the same time, the reward will be distributed or the cost will be distributed. So if Alice is coming like this, Bob is going like this, they technically reach at the same time, obviously this reward will be distributed half. So two, again, if it's a reward or a cost, both will be done half for both of them. And ultimately, if the Alice reaches any leaf node, she will simply stop moving. It is not that, okay, Alice will come here, then go here. No. If Alice reaches any of the leaf nodes, she has to stop moving at that point itself. Now, your main task, as if you can break it down, you can simply see that Alice, again, don't be confused on multiple, big problem statement. Just simply break it down. Alice can move towards the leaf node. So obviously, Alice has only like all these possibilities of moving like this. That's it. While Bob has a fixed aim, he has to go towards a node 0. Now, in that case, let's simply take one thing. And again, we know that again, we only have to find the score of Alice. We are not concerned about the score of Bob. Why Bob is useful? Because Bob will impact the score if Bob comes in between the path of Alice, which means that obviously if Alice is moving like this and Bob is moving like this, because Bob has moved from here, he will put the score as 0, and both are reaching at the same point here, the score will be half. So if Alice is coming in this path, Alice will get a score of -2, 2, 0 and 6. That is the reason I have to make sure that Bob impact is also counted. Now, let's break it down and let's say, okay, I know because Alice can move anywhere and Alice movement depends upon what current value there at the current node. But that value will be determined by Bob. and Bob path is fixed. Bob will move from his location to 0. So Bob path is fixed. Because Bob path is fixed, let's make sure that we can get the correct amount at that path. What I mean by correct amount? Obviously, I know that Alice will start from 0 and I know that Bob has to reach that node 0. So I will get, okay, what should be the correct values considering both Alice and Bob would be coming towards each other, right? I will try to compute that. Again, I will not move Alice, but I will try to think that because obviously Alice will start from node 0, Bob has to reach Alice. So obviously here will be just one path. In that one path, what will be the cost or the amount in that path itself? I want to compute that. For that, the first thing I will do is get the path, right? And after getting the path, I will get the correct amount. So I have broken down into two steps. So firstly, I broke down into Alice and Bob. Then I realized, okay, let's stick to Bob first. And in the Bob, I realized, okay, get the path first. You know what the path Bob will take. And obviously, then I will correct the amount in that path. Now, to get the path in any specific tree, how I can do it? Obviously, when I have to maintain a path, I should be able to get the path, or I should say that, okay, if I say, okay, from A reach to B, and if I ask you that you have to retrace this path, how will you retrace a path? You will retrace the path by simply going back. Okay, C, D, E, and then E's parent is A. So this is how I can retrace the path, which means that retracing a path will technically need a parent for every node. So for B, I have to maintain the parent is A, for A, the parent is D, for D, the parent is E, for E, the parent is A. That's how, if I move from A to D, while I am standing at D, I can retrace the path back to A, and that's how I can simply get the path. Now, if I know I can get the path, let's see what I will take. I will take the parent. By default, I will start from node 0 and start and doing my traversal up till node 3, which is nothing but my Bob's location. And then from Bob, I will retrace it back to get the actual path to my parent, or to my Alice, or to my node 0. Now, is it like, do I only need simple path or I need something else? Obviously, everything depends upon the distance, right? Because the cost will depend upon the distance. Up till this point, Bob will keep on putting the nodes as 0. At the midpoint, it will do a half. And these locations he will not even touch. So obviously I have to maintain the depth also, which means that how much, again, you can maintain the depth from here as well or here as well, whatever you want, but you have to maintain the depth, that okay, how much, or maybe the distance, you can say anything. So in this case, you could use even a BFS as well, because it's simply a distance which you are maintaining, right? Right now I have done DFS, but you can do the BFS as well. But if you're not sure what DFS is, make sure that you come to tree and just solve the easy problem. You'll be good to go. Now coming on back, we will solve a simple simple DFS in which I will start from the node 0, parent is -1. Currently my depth is 0, parent is -1. Then I go to next node. Next node as a next neighbor. Okay, next neighbor I go to, node is 1, parent is 0. So depth will be 1, which is nothing but previous value plus 1. Now, as I go to next node, obviously it's a DFS, so I will have two options to go to. Then if I just go to this option, node will be 2, parent will be 1, depth will be parent plus 1, which is 2. Now, same way, if I would have gone to 3, then node will be 3, parent will be 1, depth will be, parent plus 1. Now, I have reached my node, so I can stop here as well, or either if I want, I can go here as well, just go on to next node. My node will become 4, parent will become 3, depth will become 3, and the parent will be 3 itself. Now, technically, I have stopped here, or let's say, if I have got my result. Now, I can use this to backtrack and trace back my corresponding actual path. How I will do it? Okay, let's see. I am at this specific depth. Now, I will start the reversal just to retrace the path. I will start from Bob. I know his parent is 1. I know the current depth, like the actual current node is 3. Now, what is the depth of this 3? I realize, okay, the depth for this, what I have computed is the Alice. I have computed the Alice. So whatever I have computed, so whatever is stored here, this depth, it represents the distance from Alice. So I know the Alice distance with the help of this. I know the Alice distance, which is 2. What is this depth then? Obviously, now I'm retracing back my path, right? So I can keep a new variable which will say that my depth is 0, then my depth is 1, and depth is 2. So with that fact, what I did, I started my traversal from Alice. I was going towards Bob, and I was maintaining the distance d equal to 1, d equal to 2, and so on and so forth. Now, I also maintain the parent, which will help me retrace back. Now, with the help of my parent, I am retracing back. And here also, I am computing distance d equal to 1, d equal to 2. Now, this will help me because I know that I am right now getting this distance because, simple addition. I am able to retrace back because of my parent. I have computed this already while I was doing a simple DFS from Alice to Bob. And thus, I know this distance, I know this distance. And I know that if this distance is less, obviously this node will become 0. If this distance from Alice and Bob are equal, it will become half. And if Alice distance is less than the Bob distance, it will not change. The amount will not change. And thus, I'm maintaining the depth, or you can say the Bob distance as well. This is the Alice distance, which means the distance from Alice, and this is the Bob's distance. Cool. Let's see how we'll do it. So right now we are at here. So the D0. Alice depth is 2, which means that Alice depth is 2, Bob depth is 0. Obviously, Bob's depth is less, so the amount will become 0. So this amount will become 0. Okay, let's go forward and retrace back. How I will retrace back? I will go on to my parent. So this current will go on to the parent. So now I will go on to my node 3. Sorry, no, node 1. So now I am at node 1. So which means I'm current at the node 1. For node, I'm maintaining the parent already. In my parent, if you remember, I had maintained the parent for every node. So for node 1, I had maintained the parent, right? So same way, I can easily get the parent. So this is already, I have done pre-computation. So all like these two things I have already pre-computed by the previous step. Then obviously, as I went on from depth 0, Bob depth, I will increase that to 1. Now again, now the Alice and Bob depth are same. In that case, do the amount by half. So the amount will be now become half. Okay, now let's proceed forward. How I will proceed forward? I will go on to my parent. So current now will go on to node 0. So now my current is node 0. Obviously, with that the parent will be 1 and depth will be 0. Now the Bob depth is 2. Now the Bob depth is higher, which means the distance from Bob is higher than the distance from Alice. Obviously, in that case, the amount should not change, or the amount will remain as is. So I will keep the amount as is. Now in the next iteration, I will go to my parent. So this current will become -1, and thus the current becomes -1, which means it was a default value which I put up, right? So I have to stop right there. So I can stop either at current equal to -1, which is the next step, or after I have done this iteration where the parent has become -1. Totally up to you. In our code, you will see that we have done at current equal to -1. Now, with that fact, now my amounts are corrected. With that fact, now the amounts are corrected, which means now the amount look like this. Right now, if the amount looks like this, now it's a simple fact that you have to start your traversal, right? You have to start your traversal and make sure that from starting of this node, you can go on to all the leaf nodes and obviously just take the values here, because now there is no use case of Bob. I can simply go on to all the leaf nodes. Now, what I will do, I can use a simple DFS. How? Let's see. That simply start off from some node and just obviously you want the maximum score, right? So even if this node would have multiple children, you would have taken the maximum from each children. So I will take the current value, and again, I cannot discard this value. I have to take the value. I have to take all the values now. So I will take the current value and I will ask maximum from my children. How I will ask? Okay, I will ask maximum from my children. The child is only 1 right now. So it is a simple DFS call, right? Again, if you don't know DFS, I'll highly recommend that you can just, go to graph and just to solve the easy problem. You will be very good to go. And medium will be, there are a lot of medium problems for graph as well. Now, coming on back, we realized that, okay, I will ask my child. The child will say, okay, my score is 2, and I will ask max from my child. But for 1, we have 2 child. One is this, one is this. So it will ask for 2. 2 will say, okay, I am 2, and I will ask max from my child. But I don't have any child. Okay, so I can put up as 0. Or I can say that by default, I will have an int minimum value. Because why int minimum? Because I can have multiple children. I want the maximum out of those children. So I will have default as minimum. If I have no children at all, the value will be 0. Else it will be the maximum value from all the children. So right now it's true. Same way, this will be computing. So 0 and maximum from his children. His is only 1 children. Again, the DFS will call, the actual DFS call will go here as well. But still, you will see that it will be 6. So he will get 6. So you will see that for 1, it has 2 children. This one and this one. He will take the maximum out of them. So he will take 6. which means I will come up and I will get the 6. So I will replace that by 6. Now, for this value, the value will be 2 plus 6, which is 8. Now this 8 will go up, this 8 will go up, and it will be added here, 8, right? Minus 2 plus 8 will be 6. And that's my answer, which I will get the maximum from all, from entire tree. And how I did it? I did simple 2 DFS back, retracing back the path, correcting the values, and then just running the DFS again just to get the result of my actual DFS or from Alice. Let's see the code. It's exactly same as what we did. Firstly, we initialize some variable. Why we need it? We will do a starting DFS traversal just to get the path for my Bob to Alice. So for that, I'll do a first DFS. But before that, make sure that you build the graph, simple adjacency list. And then when I will do a simple DFS, exactly same as that what I did in the dry run, that my DFS will update the depth and the parent for, every node, and making sure that it will go on to all the neighbors. Now, because it's a tree, so I don't need a visited array. I can simply make sure that I don't go to parent. And then I will simply do a DFS for my neighbor, making the parent as node and increasing the depth. With that in mind, what will happen? I will start off my DFS from Alice, and ultimately I will reach the entire tree. But in that meanwhile, I will have also reached my Bob, and with that I will have everything, every node in between. I will have its corresponding depth and its corresponding parent. For Bob, I have his parent. For his parent, like this node, I will have his parent. For this node, I'll have his parent. For this node, his parent. And for A, like I can put the default parent as -1, which I have put up here. -1 is default parent. Now, when this is done, which means I have found the depth and parent, I have to now retrace back the path from Bob. So I will take the current node as Bob and Bob depth as 0. Again, as I told, there are 4 variables which I need. Other 2 variables will be derived from this computation which I have done in the previous step. Now, until my current becomes -1, as I told in the dry run as well, if the depth of current, this is Alice and this is Bob. If it is more, make sure that you put it as 0. If it is equal, make sure that you put it as half, and there's one else condition in which nothing will change. Now make sure that you go on to your parent and will keep on going until you reach the parent of -1, making sure that every step Bob depth is increasing, because I'm comparing Bob depth with the Alice depth. Just distance, Alice distance, Bob distance. Now when this is done, now my amount is corrected, right? Now I can run the final DFS, which is the DFS2. Again, a similar kind of DFS. Is just that now I have to make sure that I take the maximum from my children, or maximum profit from my children. By default, I will initialize with the minimum value, and with that I will take the maximum from my children, which is nothing but asking the DFS. And if the child has reached the leaf node, which means it has no children at all, and if I have no children at all, which means that the maximum profit will remain as is, in that case, return your cost. If you have any child whatsoever, then your cost plus the child cost, and again maximum child cost. And that's how I can simply keep on returning that. Again, a very simple sweet DFS code, and with that you will be good to go. Again, if you are confused in DFS any way whatsoever, please make sure that you come on to graph and just solve a couple of problems in easy and medium, and you'll be good to go. Now with that, you will see the time complexity for this. Obviously, initialization O of n, simply making the tree O of n, one DFS O of n, another backtracking, another retracing back O of n, another DFS O of n. Technically, time will be O of n and space will be O of n. Now, somehow people are very interested in running that DFS in just one time. Right now, we ran 2 DFS, this one and this one. Although it's a very intuitive and the most straightforward solution which you should actually do. But for the folks who are more interested, but again it's unnecessary, they can watch this one also, which is done in one DFS. Now again, as I mentioned, this previous one can also be done via BFS itself. So there is no as such hard and fast rule that you cannot do via BFS, because obviously it's a simple retracing of path and simple going on to all the leaves, which can be done by simple BFS as well. Now, if you want to do by a simple DFS, let's see. Again, it's technically not intuitive, so please make sure that you understand what I'm telling. I will just simply explain you the dry run itself, how we will do it. So right now we understood that we cannot now retrace back, right? We cannot now get the corresponding depth, which means that I have to compute the actual cost of a path while coming up. and not while going down. So earlier I was computing the path while going down, and I was asking my child, okay, what is the maximum cost which you can give me and all that stuff. But now my child would never know that his value might change, because now I will be computing these values while I'm coming up, and thus these values can actually change. So what I will do, okay, I will still do a simple DFS, because right now that's a task, because earlier we did 2 DFS, now we have to do 1 DFS. But still, how can we improve it? Obviously, I will keep on going down. I will have to maintain a depth, because that depth indicates the depth from the Alice, and then my Bob's distance will be there, okay, distance from the corresponding Bob, and then I have to maintain the correct amount itself. So what I realize, that as I am going down, I will be simply maintaining the depth, which will tell me the depth from Alice. But as we remember in the previous step, I have to maintain the distance from Bob as well. So which means that, because again, if you don't know how a DFS works like this: that you go down, and then you come up. Then you go down, come up. Go down, come up. So when you are coming up, this is the step which you can perform in the code after the recursive piece of code. So obviously, while I'm going down, great, I can maintain this depth while I'm going down. But while coming up, because I know that my Bob will be down, so while coming up, I will be easily able to compute the distance from Bob. So this is something which I will be computing while I will be coming up, which means that this will be computed while after the recursive step. So after DFS step, this will be computed. Before recursive step, this will be computed. And ultimately, I will be needing to change the amount, and let's see what that amount will look like. So let's start off and let's see how we can do it. So we'll start off a simple DFS with a node having a parent and the corresponding depth, because we will maintain that depth, right? And then the maximum profit, which I can get. Again, I can take it as a global variable also. I can take it as an inline variable also. I can take anything. But again, I have taken as a reference. So you will see it's a global variable technically. So right now the node is 0, the parent is -1, no parent at all. The depth right now is 0, and so far no maximum profit. Now to get the maximum profit, again the same formula, that ask your child, and out of all the childrens, get the maximum child profit, right? Whoever, like if you have multiple children as well, whichever child can give you the maximum profit, that's gonna be your answer. So obviously, as in the previous step also I'll put the default value as int minimum, and whoever child can give me the maximum profit, that I will take it. But maximum profit from the child, I will add to what? Maximum profit. Okay, let's say I got the maximum profit from the child. That's great. That's the same thing which I did in the last step as well. But I will add to what? Earlier I was adding to -2, which is the current node value. But right now this -2, which is the current node value, will change depending upon distance from Bob. So technically I have to maintain or find out the distance from Bob as well. Now, as I mentioned, that if the distance from Bob, if it is more than the depth, which means the amount will remain as is. If the distance from Bob, if it's equal to the depth, I will say, okay, it will become half. Elsewise, okay, it will become 0. So the actual amount which you have depends upon, again, this distance from Bob. If it is higher, which means that my Bob is like you are here, and distance from Alice is small, and Bob distance is large. Obviously, you are in Alice territory, and thus the amount should remain same. If you are in Bob's territory, obviously the amount will become 0, because Bob's would have stepped onto it much more earlier. So with that, we realize that because I need distance from Alice, like distance from Bob, to figure out what amount I should actually keep here, and that amount technically I will add from the maximum child which I will get, which means that this thing entirely is the most triggering factor. When I have this thing, which means when I have the amount itself, which is kind of the replace of this specific profit. So this total is nothing but indicating what should be the current profit, or is this -2 should be replaced or not. When I have this, so I will simply take a -2, which is, it can be -2, it can be half as well, it can be 0 as well, anything based on these conditions. My total is nothing but this thing will change, and because of that I will be, and again I will add the maximum child profit which I can get from any of the child, and this will be my current profit, or I can say maximum profit for this specific node which I can pass on to my parent. Now Everything looks similar to the previous step. The only thing or the only catch here is how will I maintain this or get this? As I mentioned, as this thing can be computed only when I'm coming up. So I have to firstly go down, and then while coming up, I will get this. Right? Okay. Now, again, I know that going down is hard, but still, let's try. Okay, if you go down, again, I was referring a tree. Now, going down in a tree, you will go on to node 1. Okay, the same logic here, the same funda. Node, I'm at node 1. The parent is a 0. The depth now has become from my parent. Earlier the depth was 0 here. Now the depth has become 1. Maximum profit still unknown, because for that I need to know about my children. Which means I will again go to my children. Okay, for this child, I will now have to make sure that, okay, for this child, I'll compute the same things. But for this child, because it's a leaf node, so what should be the distance from Bob? What should be the distance from Bob? Now, that's the most interesting part, that for every node, I will take the distance from Bob as infinity. But only the node which is the Bob node, I will take the distance from Bob as 0. Why this is useful? Because while I will be going up, I will take and update the node once distance from Bob as 1. And how I did that? I did that, okay, I will have any child which has infinity, one child has 0, which indicates, okay, this is the correct child. So minimum value, minimum, again, that is the reason by default I could have put up minus infinity as well. No, this will tell me, that because it's minimum, because it's 0, this is tell me that okay, 3 was my correct child, and that is the reason I am utilizing the correct child to add a +1 to it. So I will say distance from Bob for node 1 will be minimum out of all the children. And again, minimum for distance of Bob out of all children, because one child has infinity, one has 0. So I'll take minimum, which is 0, and then add a +1 to it. With that, I will get the distance from Bob as 1. So yeah, the distance of Bob for node 1 will be 1. So for this node, it will be 1. If for this node it is 1, now I can easily compute the total for it. Because the depth was 1, the distance from Bob is 1, which means it's an equal distance. In equal distance, I have to divide by 2. So I will get this node by 2, which means my total, or I should say the node profit value for this node has become equal to 2. And I have mentioned that this is the profit value I have for this node. I will add this with my maximum of children. And I know the maximum of children, okay, wait, is gone. Yeah, maximum of my children is current value I have put up as 2. And this was possible because of my distance from Bob. And this was possible because of my actual distance from Bob, which was computed by taking the minimum. And because of that, I will add with my current child, or the maximum for my children, and because of it, you will see the maximum for my children will be 6. I'll simply add it, I get a 6. So I get the maximum profit as 8. This is what? This is at this current step of 1. And technically, this maximum profit is nothing but the maximum child profit for the previous node. So if you remember, in the previous node, I had asked for maximum child profit. I'll update that maximum child profit as 8. As 8, I'll update it. And current value was -2. How to get that? No worries. Firstly, I will get the distance from Bob. It will be distance from my node, from my child, which is 1. Adding a 1, so I'll get a 2. My distance from Bob is 2. My current depth is 0. My depth is 0, which is less. Distance from Bob is 2, which is higher. My total will become as is, which means my total will be nothing but a -2. I'll replace that with a value of -2. I got the value from my child as 8, which is the maximum child. Thus, my value is 6. And thus, because my DFS has now stopped, and this is what I will return. Cool. Again, this is a very tricky. I bet no one will explain you this. And even if they explain, they will explain you on high level. But I made sure that I did in complete dry run. Again, notes, you can find it on the website and everything for you to follow up. Now, let's see the code. It's exactly same as what we discussed. So firstly, the same initialization, the same graph making, just the DFS will start up. This is the node, this is the parent, this is the depth, this is the in amount array, and this is the maximum profit which I have passed by reference. Because if you remember that this maximum profit is now the profit for a child, right? This is the same reason I have passed by reference. Again, you can do it by value, by global variable. There are multiple ways to go about it. Now, I mentioned that when the node is a Bob node, then only put it as 0. Elsewise, put it as infinity. And this distance from Bob will be updated while I will be coming up from recursion. And coming up from recursion, which means firstly I will go down in recursion, and then while coming up from recursion, I will be updating the distance from Bob. This is while I'm coming up, right? Okay. Now while I'm going down, I will have to compute the maximum child profit, right? Which will be simple DFS, go on to neighbor, the parent is node, the depth will be increased by 1, and then this is the maximum child profit which I am kind of passing. You will see this maximum child profit is nothing but is, again, I'm just passing this and taking a reference. If it is a leaf node, then obviously the current value is the value, elsewise the current value plus the maximum child profit. Current value will be derived from the distance from Bob, and the distance from Bob is derived while I will get out of DFS, which means while I'm coming up while doing the DFS. So how I will go about it? I'll simply ask my Bob, okay Bob, out of all the child which you have, take the minimum and add a +1 to it. And that's how I'll get the distance from Bob. With the help of distance from Bob, I will get the total amount. With the help of total amount, I will be able to add that to my maximum child profit. Now, this is my new max profit, which I will be passing up. And this passing up will actually, can help to act as for the next specific child, whichever I have. Cool. I hope you guys got it, and I hope that this, again, that's not at all intuitive, and it might bit feel a bit overwhelming, but if you see the dry run, you will just understand that. Again, as I mentioned, that this max profit is going here, going here, and this child is actually, you'll see that this DFS is now calling with this specific child. So again, I have passed it by reference. You can take it as a global variable as well, just to solve it, by on your own. Now, time and space both are exactly same. It's just that one DFS is now eliminated. Cool. I hope you guys got it. Please make sure that you hit the like button and you can share with your friends. It will be very, very, very grateful. Again, it takes a lot of effort, to make these videos, and it feels very good if you can like it and share with your friends. Bye bye. Take care. Please, please, please share. Bye bye.